Okay, so this is the line tracker circuit to control the line tracker. Here we're testing it without the line tracker itself, but we're using LEDs to represent the outputs for the motor power. So the first 4 LEDs represent the left motor power, and the second 4 LEDs represent the right motor power. Here we don't have the direction outputs, because for the right motor they're always 0, and for the left motor the first bit is always 0 and the second bit is always the same as this output here. So which means that the right motor always goes forward and the left motor goes forward usually, but when this one goes to 0 to 1, the left motor direction goes to 0, 1, which means that the left motor would go backwards, which happens in the big left state. So yeah, let's power it on. So here we have our clock working. This is our register. This is our programmable logic device. The LEDs represent the outputs, and these are the inputs. So these two are the most left inputs in the line tracker. So this is L0 and L1, and these two are the most right inputs in the line tracker. So this is L6 and L7, and we will switch these inputs to represent what would happen in the real life when testing the line tracker. So first we can see that all the inputs are at 1, which means that the car should be going straight. So we have our straight state. Both outputs are 0, 1, 1, 0. So the car is going straight and going forward with the same power in both motors. And then we can maybe switch L6 to 0, which would mean that the car sees the right motor, the right sensor. So let's switch it to 0, and we can see that our outputs go to the turning right state. So left is 1, 0, 0, 0, and right is 0, 1, 0, 0. So this shows that our car could turn. And then when it gets to the first intersection, it would also see the left input, so it would start the big left state. Both of them are 0, 1, 0, 0, 1, 1, but now this one is a 1, so our left motor goes backwards and our right motor goes forward, so we have the big left state. And as our design goes, first time both of them will go back to 1, which is in the middle of the turn. We're still turning left, and then when we finish our turn, our outputs should go to 0 again. So they both go to 0, and we can see that we go back to the going straight state. And again, all of our previous behavior still works here. So if we stop seeing left, we should turn right, which happens. And if we see both of them again, which would be the second intersection, it just keeps going forward. It doesn't turn left. So this is how it works, and this is our test for the line tracker.